Okay, let's go ahead and finish and do this answer key here for homework number 4, unit 4. Make sure your name is on the homework. Actually, you should have already been turned in now. Let's look. Question number 1. What is the formula used to solve the gravitational force problem? Well, F sub big G, not little g, big G, equals big G m1 m2 over the distance square. Label what each variable in this equation means. Well, we can do that. F sub big G equals a gravitational force. Okay, big G is Newton's constant. M1 is the mass of object number 1. M2 is the mass of object number 2. Okay, and then the last one, lowercase d, stands for the distance between the two objects, right? So let's keep going. Number 3. Number 3 here says Mars has a mass of about 6.4 times 10 to the 23rd kilogram. And its moon, okay, has a mass of about, so looks like we got 2 masses already. If the distance between the 2 planets, they gave us distance, what is a gravitational force? What is the F big G? Okay, so the F big G equals big G m1, m1, m2 over d squared. Let's go ahead and fill those blanks in so we can answer this and get this one checked off. Now, big G is actually Newton's gravitational constant, which is a number of 6.67 times 10 to the negative 11th power. Mass 1 is 6.4 times 10 to the 23rd power. And mass 2 is 9.6 times 10 to the 15th power. Again, use parentheses in the calculator, please. Over the distance squared, which is 9440000 parentheses square. Okay, again, I like to do step by step. I like to do the top numbers and then the bottom numbers, okay? Again, though, I make sure that I use parentheses. So 6.67, second key comma to the negative 11th power, close parentheses, open parentheses, 6.4, second key comma to the 23rd power, close parentheses, open parentheses, 9.6, second key comma to the 15th power, equals, I got 4.098 times 10 to the 29th power. Let me go ahead and square this at the bottom. Again, I like to use parentheses for 9440123, close parentheses, 9440123, close parentheses. I get a number down here of 8.91 times 10 to the 13th power. Now I'm going to go ahead and do my division, but again, though, I want to use parentheses. So 4.098, second key comma to the 29th power, divided by, open parentheses, 8.91, second key comma to the 13th power. I end up with an answer of 4.599 times 10 to the 15th Newton. Okay, let's look at the next one. Find the gravitational force between first mass and the second mass, if the distance between them is 0.3 meters away. Okay, we can do that. So we're going to use our same equation. F big G equals big G m1 m2 over d squared. Big G has a constant of 6.67 times 10 to the negative 11th over m1, which is, doesn't matter which one you plug in first because you're just multiplying over the distance of 0.3 meters squared. Oops, squared. Again, I'm going to go ahead and do the top and then do the bottom. 6.67 second key comma to the negative 11th power times open parentheses 0.5 close parentheses times open parentheses 0.7. Okay, I multiplied those three and I got 2.33 times 10 to the negative 11th power over 0.3 times 0.3, 0.09. Now I'm going to go ahead and do my division. But again, though, this is just me. I like to use my parentheses. So open parentheses 2.33 second key comma to the negative 11th power divided by open parentheses 0.09 close parentheses equals 2.5. I'm going to round it up to 9 times 10 to the negative 10th power newtons. Okay. If the mass of each of the balls from the problem number 4 was actually 0.9, what would the distance have to be in order for it to have the same gravitational force? Okay, we're going to use the same equation. Big G m1 m2 over d squared. But we're going to change the two masses. We're going to keep the newtons and we're looking for the distance. So let's do that. 2.59 times 10 to the negative 10th power equals, the gravitational number is a constant, so go ahead and write that in. It's going to be the same no matter what. The mass is actually changed to 0.5 for both of those balls. I'm sorry, 0.9 over distance squared. That's what we're looking for. Okay, so I'm going to go ahead and multiply the top row and let's get one number here. Open parentheses 6.67 second key comma negative 11th power multiply open parentheses 0.9 close parentheses open parentheses 0.9. I got 5.40 times 10 to the negative 11th power. Now I'm going to have to algebraically rearrange this. Could I put this in the triangle? Absolutely yes. But I'm going to go ahead and let's do my algebra. If I multiply this side by distance squared, that cancels out. If I multiply this side by distance squared, I still need to get distance by itself. So to do that, I need to divide this side by 2.59 times 10 to the negative 10th power. Now that cancels out, but I still have to do it on this side. 2.59 times 10 to the negative 10th power. So d squared equals, let's figure this out. Let's go ahead and do the division. Again, though, I'm going to use parentheses. 5.4 second key comma to the negative 11th power, close parentheses, divided by, open parentheses, 2.59 second key comma to the negative 10th power equals 0.2, and I'm going to round it 1. Is this my answer? No, it's not. This is d squared. So please don't forget to square root this. So d equals second key square 0.21 equals 0.4, and I'm just going to round it up to 6 meters. Okay. So let's go ahead and keep looking or keep going. We're on number 6 now, looks like. Okay. Find the gravitational force of a person, here's their mass, that would experience while standing on the surface of the moon that has a mass of, here's a second mass, and the distance between the person and the center of the moon is, I got the distance. So we're going to use our same equation, F sub big G equals big G m1 m2 over d squared. Okay, let's go ahead and plug in that constant number that Newton gave us, 6.67 times 10 to the negative 11th. Multiply it by 67.5. Multiply that by 7.35 times 10 to the 22nd power over 3.84 times 10 to the 8th meter. But wait a minute, that number is squared. Okay, so now it looks like we're ready to go. Okay, I'm going to multiply the top numbers, multiply the bottom numbers like I've been doing this every time so far. I just want to make sure. Open parenthesis 6.67, second key, open parenthesis 6.67, second key to the negative 11th power, times that by open parenthesis 67.5, close parenthesis, multiply that by open parenthesis 7.35, second key, comma, to the 22nd power equals 3.31 times 10 to the 14th power. Okay, now let's go ahead and square this at the bottom. Open parentheses 3.84, second key, comma, to the 8th power. Multiply 3.84, second key, comma, 8th power. Close parentheses. 1.47 times 10 to the 17th power. Now I can go ahead and do the division over here, and let's do that. Parentheses 3.31, second key, comma, to the 14th power, close parentheses, divided by open parentheses 1.47, second key, comma, to the 17th, close parentheses. Gravitational force equals 0.0023 newtons. Okay, let's keep going because we're not done yet. Number 7's where I'm at now. What is the acceleration of a car experience? So, question mark A. If it has this mass and the engine applies a force of 200 newtons, F equals MA, 200 for the force, the mass is 15,000 times acceleration. I need to solve for acceleration, so let's divide by 15,000, cancel, divide by 15,000, so 200 divided by 15,000 equals acceleration of 0.013 meters per second square. There we go. All right, not bad. Let's keep going. Number 8. One lucky CHS student got picked to be the first high school student to travel to Neptune, but had to fit all of the requirements. Here they are: over 5 foot tall and exactly 220 pounds. When the student reaches Neptune and takes their first step on the planet that is 3.9 times larger than Earth, what will be the mass and the weight force of that student exerting on the planet Neptune? Okay, so let's figure this out. First thing, are we okay with 220 pounds? No way. We need to change that number into a mass number in kilograms. So let's do that. 220 divided by 2.2 equals, so 220 divided by 2.2 equals 100 kilograms. Now that's a good number that I can work with. Now, here on Earth, weight force equals mass times acceleration. So if I have the mass of 100 kilograms multiplied by 9.81, the acceleration comes out to a weight force of 981 newtons. If they go to Neptune, it would be the same. It will stay the same because mass will always Forgive me. Let me find my, here we go. Forgive me. Let's go backwards. Here is the mass. And this will always stay the same. Now on Earth's gravity, sometimes we call it A sub G, okay, is going to be 981 newtons. Now this will change. Okay, it will change due to gravity. And if Neptune is 3.9 times larger means multiply, than Earth, we're going to go ahead and get this 981 and we're going to multiply it by 3.9. So where are we at? 981 multiplied by 3.9 equals 3,825.9 newtons of weight force on Neptune. This is going to be Earth. This number over here is Neptune because Neptune has a greater gravitational pull. Okay? So mass, 100 kilograms. No matter where this student travels, the weight on Neptune is 3,825.9 newtons on Neptune. On Earth, that number would be 981. Okay? So let's keep going. Alrighty. Looking at homework number 4 still. On the back side, answer the following questions using the free body diagram to the right. So they're asking me, well, what is the normal force of this diagram here? And the normal force is that upward pull, upward force. It's going to be because it's sitting on something's helping to push it up. 2 newtons. What is the applied force? The applied force is going to be, normally to us, it's going to be to the horizontally. But look, what is the weight force? So weight force is obviously going to be some type of gravity pulling down. So this number is used. This number is used. The applied force has to be this 5. And the frictional force has to be here. So this is my FA, F sub W, F sub N, F sub F. Okay? What is the gravitational force in the diagram to the right? Well, the gravitational force is the same thing as the weight force, which is 5. What is the frictional force? 3 newtons. What is the net horizontal of this diagram? Horizontal is over here. So 5 take away 3 because those vectors are in opposite direction equals 2. What is the vertical? Up and down. So 5 take away 2 equals 3 newtons. Okay, so overall, let's draw the overall net vector and find the net force of this using this compass below. Okay, well, horizontally, 2 newtons, who wins? To the right. Vertically, up and down, who wins? Down. So it's going to be down and towards the right or southeast direction. It's going to look like this. Now, remember, you're going to start over here at the x-axis and you either go down or you go up. Our vector is in this quadrant over here. So we're going to go down, and that's my theta. Okay? That's my unknown. Also, what's my unknown is the magnitude of that vector. But if I look at this, I can see that, look, it produces a right angle. Opposite to that right angle is my hypotenuse. The theta and the right angle produces my adjacent leg, and what's left over is my opposite leg. Okay, so now let's go ahead and step 1 is going to be SOHCAHTOA. 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 Alrighty. What do I have? Well, they told me horizontally, right here, it's 2. Vertically, it's 3. So I have the A and the O leg. The A and the O is the tan. So the tan of the theta equals the opposite over the adjacent leg. Or the tan of the theta equals 3 divided by 2. Okay, so let's clear that out. Clear 3 divided by 2 comes out to 1.5. So tan of the theta equals 1.5. Not my answer. I want to get rid of this tan. So to do that, we have to do the inverse of tan, which is that. So let's do second key tan. Make sure you're in degrees and not radians. Of 1.5, close parentheses, comes out to the theta of 56.31 degrees. That's only part of my answer. Second part is going to be Pythagorean. I'm looking for the hypotenuse, which is a C. So 3 squared plus 2 squared equals C squared, right? So let's make sure that 3 times 3 is 9. 2 times 2 is 4 equals C squared. 9 plus 4 is 13 equals C squared. Not my answer. I want to get rid of that square. So to do that, we need to square root it. So I do not know the square root of 13 off the top of my head. I should, huh? 3.6. So C, or the hypotenuse leg, equals 3.6 newtons. All right, we have a few more questions to do before we're done on this homework. Question number 10. Well, what is the resultant vector and magnitude of the force acting on a leaf blown about the wind if 45 newtons of force is acting on it to the right and 15 newtons of force is acting up? Okay, so if it's going to the right and it's moving up, it's going to move to the northeast direction. Let's go ahead and draw that northeast direction. What do I do now? I do my X and Y axis. Okay, start on the X axis. We're in this quadrant, so we're going to have to go up to find your theta, and you're looking for the theta and the magnitude. They told me that to the right, this leg right here is 45, and up, this leg right here is 15 newtons. I see that it forms a right triangle or right angle, so go to the opposite, makes this my hypotenuse. The theta and right angle is my adjacent, and left over is my opposite. I'm going to highlight what I have, which is my A and my O. So step 1 is going to be SOHCAHTOA. I have the A and the O, so I'm going to use the tan of the theta equals the O over the A, or the tan of the theta equals 15 over 45. So that's some kind of decimal. 0.333. So the tan of the theta, 0.33. Not my answer. I want to get rid of that tan. So I need to do the inverse key. So the second key, tan of 0.33, close parenthesis. So the theta comes out to like 18.26 degrees. That's not my full answer. It's only part of it. Second part is going to Pythagorean. All right, so 45 squared plus 15 squared equals C squared. So 225. 45 squared is 90. Whoa. 45. It's 2025. Forgive me. 2025. We need to add those two up. So 2250 equals c squared. I've got to get rid of that square. So to do the opposite is square root it. So second key square of 2250 equals the c, or the hypotenuse leg, is 47.4 newtons. Below, go ahead and determine which one of Newton's 3 laws are they talking about. Henry pushes against the wall and the wall pushes back on her. Oh, Henry's a girl. That is the 3rd law. Soccer ball is being kicked in space and will continue to move forward without slowing down. The 1st law. Next one. A spaceship launches by blowing hot gases out of the exhaust. 3rd law. A statue is sitting on the floor and the statue pushes down with 100 newtons while the floor pushes up with 100 newtons. 3rd law. A bumper car slams into the wall and the driver's glasses fly forward. 1st law. Okay. Next one, we're going to do again SOHCAHTOA here. You're going to find the horizontal. So 10 take away 3, which is 7 newtons. And 5 take away 9 is going to be 4 newtons. So the overall direction is going to be a downward. We're going to do our x and y axis. Starting at the x-axis, here's my theta. This produces a right triangle. To horizontally, this is 7 newtons. Vertically, this is 4 newtons. I come over here and I say, oh, that's my hypotenuse, my adjacent, and my opposite leg. I'm going to highlight what I have here and what I have here. And I'm going to go ahead and break it into 2 different steps. Step 1 is SOHCAHTOA. I have the A and the O, so we're going to do the tan of the theta equals O over A, or the tan of the theta equals 4 over 7. Okay, 4 over 7. So we can do that division, but after that, please make sure that your calculator is in degrees, which equals 0.57, not my answer. The opposite of this tan, to get rid of this tan, is the inverse. So second key tan of 0.57, close parentheses, the theta equals 29.68 degrees. Second part here is a squared plus b squared equals c squared, or 7 squared plus 4 squared equals c squared, right? So we got 16 on this side, right? And we got 49 on this side. 65 equals c squared. Not my answer. Look, I want to get rid of that square, so I have to square root it. So second key square of 65 is 8.06 newtons. All right, well, you should be like professionals, pros by now with this SOHCAHTOA stuff. It says here that an elevator is accelerating as shown below. What is the net force on it? They're only looking at the y-axis. If they're only looking at y, which is up and down, and there's 2 arrows in opposite direction, all you're having to do is subtract them. So 82 take away 21. That's it. Sometimes, not often, but sometimes it's as simple as that. 61 newtons and up. Okay? Few more questions. And then we are done with this homework. This homework had a lot of information. It had a lot of the notes in general, just kind of compacted into this one homework. This one here, what happens to the acceleration if you double the force? So we practiced this one already on the board. Is it going to be proportional or inverse? Proportional means the same. Inverse means opposite. So what happens to the acceleration if I double the force, if I increase it by 2 times the amount? Remember, for us to do this, we're doing some kind of comparison. We're going to compare the numbers. Well, if they never gave me any numbers to start off with, let's make up our own numbers. And we're going to have to do this 2 times. In the beginning, so we can have one number to start off with, and the next one's going to be another number to compare it to. Okay? So let's start off the first one. First thing is F equals MA is my equation I'm going to use. Let's do simple numbers. 1 equals 2 times A. Why am I leaving A alone? Because that's my unknown. Divide by 2, cancel, divide by 2. A equals 0.5. Let's look over here. What are we going to change? We're going to double the 4. So instead of 1, we're going to double it to 2 equals, let's leave 2 alone. We're going to leave that variable alone. Divide by 2 to cancel, divide by 2, A equals 1. What happened? From here to here, when I compare them, it increased. What happened here? I increased. By how much? It increased by 2 times the amount, which means that it is proportional. Okay, let's try it again. What happens to the acceleration if you double the mass? If I increase the mass by 2 times the amount, is it proportional or inverse? Well, again, let's go ahead. We're using F equals MA as my equation. Step 1, let's do simple numbers. Let's just make up F is 2, mass is 2, and A is A, because we're looking for A. So let's go ahead and divide by 2 so we can solve for A. Divide by 2. A equals 1. Let's do this again because we have to compare it. We have to have 2 things so we can compare them to. Okay, so let's keep looking. What am I going to do to the second equation? Same equation. What am I changing? I'm going to double the mass. So that means leave force the same, which is 2. Leave it alone. Mass, M, originally it was 2, but I'm going to increase it. So what happens? What's the next number if I double it? That means that this becomes a 4. Equals 4A. Divide by 4, cancel, divide by 4, right? So what happens here? When 2 divided by 4, A equals 0.5. I got bigger. I started off with 1 and I got smaller. And what did I originally do? I increased it. What happens to my answer?